For the last bit of section 1.5 equations, we're going to take a look at three different types of equations that are not quadratic. And that would be starting off with the rational equation. So a rational equation is a situation, as you can see, where you have fractions in the equation, specifically rational expressions. You can notice the variables. All of the denominators have variables, some variables in one of the numerators as well. So this is a rational equation. And our job is still to find the value of z that makes this true, value or values. There might be more than one. So the way that we solve a rational equation is we want to rid ourselves of the fractions if we can. We want to do what we can so that, if we can make this into an equation that we've seen before, something linear, something quadratic, that's what we want to do because that's going to make our life easier. We know how to solve those. So what we think about here is what our lowest common denominator is. And what that might require is taking something that's not factored and factoring. So you might need to factor some denominators here. Notice that z minus 4, z minus 2, the first two denominators, they are linear. There's no way to factor them, so they're already in their factored form. The last one, however, z squared minus 6x plus 8, that can be factored. And so we can have a z and a z. Notice that with the middle term being subtraction and the last term being positive, we need to have both subtractions. And then our factors of 8 are 1 and 8, 2 and 4. So we know we need 2 and 4 to make that 6 that's in the middle. So we can see that we have a z minus 4, a z minus 2, and then we have a z minus 2, z minus 4. So it tells us that our lowest common denominator here is z minus 4 times a z minus 2. We also have to think about the fact that in this equation, there are values that z cannot be. That if this is what we get for z for our solution, it's going to cause a problem. So I want you to notice, we want to think about the values that would make the denominator 0, any of the denominators. And you can see that in our case, that's going to be 4. If 4 was a solution, that's going to be a problem because you end up not being able to get an answer because you get 5 over 0. So we can't have 4 in our solution and we can't have 2. Those things make the denominator 0. The key thing to see is with what we do next, we're going to negate all our denominators. So our equation is going to go from being rational to being something else. And in doing that, you may have the possibility of getting an answer that is actually not possible. So once we have our lowest common denominator here, as you can see, what we're going to do is we're going to take that lowest common denominator and we're going to multiply both sides of this equation by the lowest common denominator. So z minus 4 times z minus 2. I'm going to do that on the other side as well. Due to spacing, and I apologize for this, but I'm going to make it look like this just so that you can see. But you can find all sorts of other examples too online. They're everywhere. So I'm going to take this lowest common denominator and I'm going to multiply it by my first term here. And what happens is the z minus 4 simplifies with the z minus 4. And we're left with 5 times z minus 2. Then we do the same with the second term. We multiply this whole thing by our second term here. And not surprisingly, the z minus 2 simplifies and we're left with 3 times z minus 4. And then to get real exciting, notice that when you multiply this last piece, the one on the right side, by z minus 4 times z minus 2, both the factors simplify because we simplify here and we simplify here. I wasn't willing to do that yet because I needed to show you all three terms. But it leaves us with just z squared minus z minus 2. And now notice this is a quadratic equation because the highest degree is 2, and we know how to solve quadratic equations. We've already done that ourselves here. And so we just want to take a look at what this quadratic is going to look like. For us, that means, let's see, due to spacing, I'll probably have to bring it up to the other side. Let's see, okay, so combine everything here. And you're obviously welcome to pause and do some of this if you would like to see what happens. So now I'm going to bring everything to one side, and I'm going to bring everything to the right side so that I have a positive z squared. Then I'm going to subtract 8z to get minus 9z. I'm going to add 22 to get a positive 20. And then notice what happens is z minus, well, I should first go like this. I'm going to see if it factors. If it does factor, it would have to be like this. It's the only way to get a negative in the middle, positive at the end. My factors of 20, I feel like we've seen these multiple times in this section, but it is going to be 4 and 5. And so that gives us z, using that zero factor property, z equals 4 and 5. However, again, this is what can take a little bit of time for students to understand is, but when I multiplied both sides by that lowest common denominator, I took something that had fractions in a denominator and, with variables, and I took them out. And so what that means is we get an answer here of z equals 4, but z cannot be 4. If you look back at our original, you cannot plug in 4 and get something that is real, that is anything. You get, 5 over 0, excuse me. That's not a thing. So 5 cannot be a solution for us. So that means that the only solution that we have is just 5. So 4 cannot be a solution. 5 is our only solution. My brackets just get horrendous. Okay, so that is another type of equation, rational equations. We also have absolute equations, absolute value. So remember that the absolute value of something is really just, it's the distance that it is from 0. And so what that means is the inside could be a number, it could be the negative of that number, and both of those things are the same distance from 0, and that's why you end up with two solutions to an absolute value equation like this. So what it means for us is when we get an equation like 3x minus 4 absolute value equals 12, it tells us that there's two solutions that the inside could be. If the inside is 12, then the absolute value of 12 is 12. If the inside is negative 12, then the absolute value of that is 12. So whatever x creates 12 or negative 12 is going to be a solution to this. So the way that we solve it is just splitting it into two different possibilities that are linear. So we end up with some pretty simple equations once we use that rule that we have there. So notice we now just have that either the inside is 12 or the inside is negative 12, and then we figure out what value of x makes that true. So if you want, you can go ahead and pause and do that. These are not the prettiest of numbers, but hey, sometimes life gives you fractions. So we end up with negative 8 over 3 and 16 over 3. So those are our two solutions. I'm going to go ahead and stick those in a solution set. And there we go. So that's always what we want to do with an absolute value equation such as this, is think about the fact that the inside could either be that positive value that's on the right or the negative, and go from there. And then the last one we'll look at is a radical equation. So this is an equation that has a radical in it. As you can see, there's a square root here. We've got some variables going on, and there's a few things to think about when solving something like this, which is that you really want to free that x plus 11 from the square root, and that the easiest way to do that, or the most straightforward, is to isolate your radical. So I'm going to subtract x from both sides, and I'm going to get negative square root x plus 11, and that's going to equal 1 minus x. Now, personally, I don't like the negative that's there on the left-hand side. I don't love the way that I have 1 minus x on the right-hand side because of what I'm going to do next. So what I'm going to do is I'm just going to multiply both sides by a negative. So I'm going to do this, and I'm going to do this. There we go. And what that does is just give me an x plus square root, x plus 11. And on the right-hand side, it just changes the sign of everything, so I get x minus 1. This is not required. I like it. I did it. But it gives you the same answer if you just go from that line and don't multiply through by the negative. But I can because it's an equation, so I did the same thing to both sides. Now what we're going to do is we're going to free our root. The whole idea here is to solve for x. Well, I can't solve for x unless that x is free from the square root. So I think about the fact that I have a square root and the opposite operation of that. So think about the opposite operation of a square root. It is to square. So I'm going to square both sides. Got to do it to both sides. Got to do it to both sides. So there you go. Notice it's now going to free my x. So now I have just x plus 11. On the right-hand side, it does take that linear binomial and make it into a quadratic. So a couple key things here. Do not forget that this is x minus 1 times an x minus 1. A lot of students will give me x squared plus 1. That is not the case. There is a middle term there. You do need to multiply out that binomial, thinking about FOIL, FOIL, making sure all the terms get multiplied and combining them. So we get the x squared minus 2x plus 1. Now we have a quadratic, and we want to think about that. So we do have the ability to bring everything to one side. So let's do that, see what happens. 3x, and then it looks like I'm going to have a minus 10. Now, it's a quadratic. We've already talked so much about how to solve quadratics. There's multiple different ways you can do this. You should always, however, start with factoring, see if that works. So notice we have x, we have 5, we have 2, we have minus, we have plus, and this gives us two solutions. And that's going to be x equal negative 2, positive 5. Now, something that is key with radical problems. There is the possibility of getting extraneous solutions, literally meaning like extra solutions, solutions that don't make this true. So it is important to check your answers. And you can do that. I mean, there's really one way to do that. You just plug it back in, but whether you write it out or you don't write it out, it's up to you, but you do need to check them. So notice if x equals negative 2, if I plug that back in, I get negative 2 minus the square root of negative 2 plus 11, and I'm saying, does that equal 1? I get negative 2 minus the square root of 9, does that equal 1? Negative 2 minus 3, does that equal 1? And we see that negative 5 does not equal 1. So negative 2 is actually not a solution in this case. And the reason that it occurred is because we took two sides of an equation and we squared them. And even though that is a valid operation, it does allow for the fact that something you could end up with an extra solution in this case. So not all the time, but you could. So we check, and negative 2 does not work. If we check 5, we get x, don't get x, I gotta put in my 5. We get, we get 5, so I'm going back to the original, minus the square root of 5 plus 11, does that equal 1? So notice the idea here is I'm checking it. I don't know if it equals 1, I don't know, but in the first one, it did. Now I get 5 minus the square root of 16, does that equal 1? And 5 minus 4. And we see that, yes, 5 minus 4 equals 1. So in fact, 5 is a solution, negative 2 is not. But negative 2 came out because of the fact that we squared both sides and ended up with an extraneous solution. So that's a whole lot about equations. And we will see these throughout the semester, just different things that we do with some of this stuff. It will come back in the future. So we want to be really good at doing our solutions, finding our solutions to our equations. And that is section 1.5.